it before. Oh, I didn't do the camera. Okay, well, welcome back. We were out viewing the portable wind turbine back behind the Missoula College in the bullpen back there. Dr. Layton and graduate Tim Chester were going through that with us. A good exercise. Oh, I'm going to go through dimensional analysis again. It kind of dovetails into what I talked about earlier with the relation of power and energy. There's all of us get it confused too. Let's do this. That may help that relationship a little bit. It gets back to the basic physics of energy, of power. I didn't find my notes. We'll see what. So speed or velocity. Now speed and velocity are the same thing, except velocity is a scalar function. It's directional, and speed isn't. And there was a test question on that. I think maybe I took it off because it wasn't covered. But so speed in dimensions is a distance over time. Is that not right? As we're most familiar with, miles per hour, or feet per second, or, as we're learning about in these courses, meters per second. That's the SI units, right? So acceleration is velocity dot. Remember what that is? What's a dot mean? Rate. Yeah, rate of velocity, which is velocity over time. So if velocity is distance over time, times time squared. So it's distance over time squared. I'm going to abbreviate. Okay. Yeah, it's feet per second. So acceleration. So if you're going a certain speed, when you're accelerating, it's how fast you're speeding up. Okay. It's meters per second per second. I'm going miles per. I'm going 30 miles per hour in my car. There's a boulder coming down the hill, side of the hill. I'm speeding up. Okay, I'm revving it up, and the rate I am going is going up by that rate of accelerations. Yeah, per second. So I might be speeding up by 30 miles per second, or whatever the rate is. That'd be awful fast, but okay. So that's the and you look at SI units. The SI unit for distance, again, is meter, and for time is second squared, seconds. So it's meters per second squared in SI units, okay, as acceleration. We'll call this A. What's force? Time-honored, time in relations to mass and acceleration. Force is equal to mass times acceleration, right? Einstein's theory of relativity, is that the one or the different one? Anyway, so now in gosh, I didn't do a very good job now. Okay, let's go as these are dimensional. I've got about half a table going here. Okay, this is dimensional here. SI here. So mass is what's the SI? What's the mass? Is just mass in dimensions. Okay. Acceleration, it's distance over time squared. And a better thing for distance is length. Okay, that's what I need in my notes. It's really the same. Distance is about the same thing as length, but dimensionally length is a better term. See where I'm going.
Is it more common to see length instead of distance?
In dimensional analysis, I think so. Yeah, because it's I don't know. I can't define the difference between the two.
Well,
So I go 200 miles to Bozeman to see my buddy. That's a distance. A length would be
I
more like a smaller
You would think the
increment
table
of
is
distance. A length is
4
a
feet
smaller,
long.
yeah.
That would be a length.
Well, no, that's a difference. Then I'm glad you brought it up. The table 4 feet long is the table has a length, all right? It always has a length, okay? But it can be described as 4 feet long, 3 meters long, and that's a unit.
Oh.
And before I took this course, couldn't differentiate between the two.
That would make
So a table always has a length. I mean, an object always has a length. All right.
because it's an object.
If we're talking about,
It turns into a unit.
but how we describe or we measure its length depends on the units we use. It can be inches, centimeters, meters, miles, cubic miles, or not cubic miles. That's a volume. Okay. And that's where I'm going here. So this, in 6 minutes, holy cow, this could be tough. So this acceleration expressed dimensionally is right here. Okay, mass. These are the dimensions. Let's throw it down here. And let's do a better job of this. Let's erase this for the folks at home that are going to look at this later. Okay.
T under there, is that supposed to be times squared?
Yes. You mean you can't remember anything? It is times squared. Okay, there it goes.
It looks like times length.
And what are the SI units for mass? Kilogram. So it's a kilogram. What's the SI unit for length again? Meter per second squared. What's energy in relation to, what's its definitions?
Energy
Related to force and distance. Energy is force over distance. Okay? Maybe that isn't right to say distance. Okay. And formula would be force times distance. Okay, and the dimension of distance is length, right? Again. Force, we just set up here is mass times length over time squared. So that's force. Boy, this is going to get really, I was going to try to be really neat with this one. All right. Times, again, length. Okay. So what does that come out to be? It's mass L squared over time squared in SI units. This is dimensions. Dimensional. SI units is mass is kilograms meters squared per second squared. Okay. Which is a joule.
That is a joule.
Yep. And when we evolve equations relating power to these dimensions or units for the power of hydro through a turbine, the power of a wave, the power of wind through a wind turbine, the power of water through a water turbine. We utilize these dimensions and units to get there. Okay. And I know that doesn't make a lot of sense until you get to the specific, and we'll be getting to specifics as we go on. And I think we looked at the wind one early in the class.
So
Yes.
we learned in chapter 1 it was power equals energy over time. Energy is power times time.
Yes.
Like, so is that just looking at it differently, or is that two separate forces
No,
and length?
no, we're looking at power and energy in more depth here. We're looking at energy as its definition of what it is, and then taking a look at that, what it is, what are the dimensions of that? And then if you get the dimensions, you go, well, then here's the SI units of it. Oh, if these are the SI units, then it gets to, oh, then we go to the SI unit of energy, it's a joule. Now let's keep going to, that's where I'm going next, thank you, is power is energy over time, right? So now we're going to do the same thing for power. So dimensionally, it's energy, as we just had, ml squared over time squared divided by time, which equals ml squared over time cubed. In SI units is kilograms meter squared per second cubed. And we know a joule per second
Per second cubed or squared?
per cube, and I wrote it wrong. Thank you, and I do that about 100 times a day. Said it and didn't write it. Per second cubed is a joule per second, which is equal to a watt. So I'm kind of going at it, I'm going back to the root of definitions of these parameters, their physical definition, all right? What is force? Force is mass times acceleration. Energy is force times distance. From those two relationships, we find out what energy is in SI units. Power is energy over time, so then we can find out what power is in SI units. Okay. Well, that's about it here. Let's go back, see what we covered. This is a important bunch of relationships here. I hope to, and I don't know if I'll get there, have a problem in one of your assignments related to this somehow. Yeah. There'll be problems specific to a derivation of a formula, but there also may be one where you fill out a table. So we did the dimensional analysis. Again, take a look at your graded assignment 2s and give me bring any questions up you want to. We didn't go into the assignment 3 preview, but we're out of time. We'll do that Wednesday, and then there won't be a lot of time for engines left. You're going to have to do a lot of there. If you got questions on any of those chapters, bring them Wednesday. That'd be good. And again, that assignment 3 is basically, or the summary 3, all you really need to do at this point for sure is open it up, get your data points. Population, carbon dioxide, and the other variable of your choice. Let me write that down.
Did you have it in there to snapshot?
Well, that's what he means.
I don't know.
Population, CO2, carbon dioxide, and a variable of your choice. So you go in there at a point in time, around the same time as you're going to do it, and 2 days later, and go on that website, write down the number for population.
Write it down?
Yeah, it's just clicking away. Oh, you can put it into your spreadsheet, but if you're not ready to do that, don't do that. Just write it down. Write the CO2 down, carbon, and then figure out another one you're interested in. Okay.
Well, I know that there's a way with how he said, reason he worded it snapshot, there is a program in your computer where you can cut a piece.
Yeah,
Cut it out.
and I'm not ready to show you that. And I don't
know.
want to take the time to show you that. You can just write it down, or you can do it that way if you want
I'd
to.
rather write it down.
But then do it again 2 days later, and again 2 days later. Then you got your base data.
Okay.
That's the data that will go into your Excel spreadsheet. Okay, and then we can go from there with it. All right?
Awesome.
So we got that done too.
Sorry, I'm taking
Okay.
a class.
No, they're not for a while yet. I got to get ready for these yahoos. You're meeting here first, or you can go over there. Probably meet here first. I don't know if anybody's over there now.
Probably. Yeah, we took it
You
down.
guys take it down? Yeah.
You get to put it out.
Brian's probably,
Yeah.
no.
We made the mess and you get to clean it up.
All right, thanks for coming again. We got a lot to take a look, and exam is Wednesday.
Wednesday.